from ISQI, the International Software Quality Institute, a leading global examination provider working with some of the largest qualification boards in the industry, including, as an example, the ISTQB. As I say, delighted to have with me Keith Yorkston from Quality Risk Management, who is a testing expert, an author, a speaker, and indeed a practitioner. And he actually is doing performance testing. And I'm really happy that he's going to be able to share with you some insight and some ideas about performance testing, which I think is particularly appropriate at the moment. Performance touches everybody who is working in this very online world that we now live in. So Keith, can't wait to see your presentation and hear a little bit more all about performance testing. So I'm going to hand over to you. Thank you.
No worries. Thanks, Debbie. Well, good afternoon, everyone. As Debbie said, performance testing. One of the funny things about performance testing that I've noticed in the time that I've been doing it is there's almost a lack of appreciation, I think is the best term, in that people will use an application, they'll use a site, and everything works fine. It's not noticed. We only tend to notice performance when it's not working. So a site might be slow. Now, I see this quite a lot, in the past especially, where I'd turn up at a very large train station in London, and inevitably, very appropriate at this time, the trains are delayed. They're delayed because there's leaves on the track. Now, you would think a 400-ton train wouldn't get slowed down because there were a few leaves, but it would happen. And the reason why, of course, is that leaves on the track lubricate the track. You've got steel wheels on a steel rail, and things don't quite work as well as they should. So everybody gets online, they get their phone, and I'm sorry, I'm going to be late home. But because they're all hooked up to the station Wi-Fi, suddenly there's a big spike in load and things start to not work as quickly as we would hope. And this is one of the things that then will spring up. You know, people might be trying to access their social media site of choice, or they might be trying to access whatever website or application that they want to hit while they're standing on a train platform. But nobody ever thinks about, well, what are all the steps in between my end client device and the servers that are running that? You know, what sort of infrastructure? Have you in fact hooked up to the free Wi-Fi, or have you hooked up through a 3G, a 4G, a 5G connection? So there's so many points along the internet backbone that we're all using that could cause a delay. But inevitably, people will go back and say, oh, the BBC website is slow. Well, no, it's probably quite fast. It's all a bit in between you and them that could be the problem. So these are some of the things that we could really look at when we are thinking about what performance is. So a little bit about me. Keith Yorkston is my name. I've done many different things throughout the years in IT. I've been a trainer in terms of the ISTQB courses, performance, security, and I predominantly work at the moment specializing in performance testing, security testing, also the author of a book on performance testing. So if you're looking to set the ISTQB foundation level performance tester qualification, that might be a good book to jump onto your favorite online a bookseller of choice. I won't say which one that everyone uses, but yes, it is on that one. Okay, one other thing I'd like to do is a shout out to all those folks at the bottom of the slide there from Pixabay. I use pixabay.com for just about every slideshow that I do. And it's a great resource. I don't get anything from them, but I like to give them a bit of a plug. So if you're looking for high quality photos to use in presentations, pixabay.com is the best one to go to. It'll be about a 45-minute presentation that we'll do this afternoon, and then we'll have a bit of a Q&A at the end. If you pop your questions into the chat, we'll be able to cover those off then a little later on. Good one. So first thing we've got to do is actually work out what is this performance thing. And this is one of the issues, or one of the barriers that I've seen quite a lot in organizations that I work in, is that one of the fundamental problems we have is everybody has their idea of what performance actually is. Now, inevitably, people would always come back and say, well, I want it to be fast. So this site will respond in what I like to call the almost Fibonacci sequence of seconds. So we want it to perform in 1 second, 2 seconds, 3 seconds, 5 seconds, 7 and 10 seconds. I can pretty well guarantee that one of those times will come up. But the problem is that they say, I want the application, the service, the website to respond in that time. But they never ever cover, okay, so what business processes? How many users are on the site? Are all those users doing the same thing? You know, Black Friday is a good example. So if you release your Black Friday sale on your website, how many of your users are going to see the banner and they're going to, oh, there's a special, click. So there's a fundamental level of psychology that actually sits behind what we think performance is. And that's something we're going to talk about as we go through. And I'm not ever going to argue with somebody that says, yes, we want the system to respond quickly. But in what way? I mean, are we now talking about from the client to the server, request, response coming back to the client? Or are we just talking about when the request hits our infrastructure, our firewall, our server, gets processed and then gets sent back out? Because there's a lot of internet that sits outside of our control that we might have to think about. So when we're looking at defining security, we need to think about the different possibilities. So the organization that you might be involved with might not want it fast. They might want it cheap. And so, yeah, our users will get there in the end, but maybe not as fast as the racing bike we saw there previously. It might be that you've got a large amount of load on your system. So now we're not talking about a single transaction going very quickly, but we might have a whole wide range of transactions that are all happening at the same time. You know, some big, some small, some on very large, expensive bikes, others on tiny little cheap ones. And so that's where maybe the surface of the road, the width of the road might come into play. So we could look at things like bandwidth, latency, packet loss on that infrastructure in between those points. But we always have to remember is that we may not be in control over a large amount of the infrastructure that request response is traveling on. It might be that your business has legacy systems. And I know that the organization that I'm working with at the moment, there is a set of legacy systems there that our new services have to integrate with. And so we need to think about how are we going to make those legacy systems work? There might have to be a layer of translation and abstraction that we have to use to be able to utilize that source of data that might exist as an old mainframe database, for instance. But now we're just talking about single things on their own. It might be that you've got a combination of those factors. You might want inexpensive. You might want, to be able to handle load, to be able to do it fairly quick. So it's getting the balance of those things that I think is the true determination of what performance is. And it's something that we need to look at when we think about defining performance in an organization. I know that where I work from day to day, from month to month, that definition of performance changes depending on who I'm talking to within the organization. But also, it's going to be different. You might have two organizations that do the same thing, two retail organizations, very topical at the moment. Do they both think about performance in the same way? So even coming up with that definition, I think, becomes very important, because it can then give the people that have to achieve that level of performance some sort of direction as to what they need to aim for, whether it be the architects, the developers, the infrastructure folks, system admins, network admins, DBAs, database administrators, or even the lowly performance tester. So one of the ways that we can do that is to actually start to break down the business processes that our users are interacting with. And a very simple way that we can do that is by putting those things into context. So we're going to talk about each one of these terms, but it's a very simple a set of words to remember. You'd like to think it was 5 W's, but we threw an H in there just to keep you on your toes. So let's look at the top one, who. Basically, it's who are the users. Now, I'm not talking about individuals, but we can categorize those as groups of users. So we might have a set of administrators, we might have a set of guests, we might have a set of whatever type of user that may exist in your systems or services that you're offering. A really easy way to look at that is just to think of, well, we've got a group of internal users. So if you think about a bank who is offering a mortgage, so there's a group of bank staff. They might be in branches, they might be in a head office on a phone, but they have an internal system they're going to use to help walk us through applying for a mortgage. There might be a group of external users that are using a different user interface, but they're going onto that mortgage application system. So here we might be in a totally different context in terms of that user interface. It might be a browser versus an internal client server application for the internal user, but they're both passing similar amounts of data. But something else that's come up, especially in the idea of the microservice world, is there is no user involved at all. So a really simple example of this might be somewhere down the line, there will be a user, but we have an application that needs a postcode lookup. So if I'm using the example of Royal Mail, for instance, they have a little service that they offer that basically does a postcode lookup. I send it a postcode, it sends me back a list of addresses for that postcode. And so, yes, there might be a user involved at the end, but where we're interacting with that service, there are no users involved. It's just getting postcodes and sending back the address range. And that might be it. So sometimes the user isn't a person. It might be another system, another service. So the first important thing that we need to think about is, who are our users? We have to know what they're doing. Not only what they're doing, because we look at that as we're going through, but we almost have to look at their behavior. We need to look and see how the users react to the technology, the systems, the services that we're providing them. And that's a really important point. I think as performance testers, we haven't paid enough attention to the users. I'll talk more about that as we go through. The next point is the what. What are the users doing? So it might be that they're following a particular user path through the system. So there's a particular process that has been developed by the business analysts, the product owners, whoever it may be. And that's the path that we think users are going to follow. Now, I said we think because users sometimes will do their own thing. But the most important thing we've got to consider is there's going to be different views of that process. Now, if I'm an end user, I'm looking at my user interface and I'm playing with the system. I'm doing things with that system. But we always have to remember is there's a big difference between the front end and the back end. So the front end, we might want to make pretty. We might want to make it usable. We might want to make it attractive. So users keep coming back to our site because they're very impressed with our user interface. The problem you get, of course, is that what comes out the back end might be totally different. And this is something we always have to consider, is that it might be great that as I start to type into a field, I start typing in, I'm looking for fruit. So I might start typing in apple. And as soon as I hit A, it might have a list of everything that starts with A coming up. And that might look really impressive to an end user. But how much work is the back end doing to be able to provide that functionality? So we've not only got to think about the user path through the system, but we've also got to think about how the system itself is reacting to the stuff that we're doing. So what is it that the system is doing? Both from a front end point of view, from that user point of view, but also from the back end work that the system has to do, the service, whatever it is that we're building. So we have to know the front end as well as what's happening at the back end. And that could be simple things from little queries, stored procedures that it's doing, all the way up to, big read writes of PDF documents, as per our mortgage application. Eventually, it has to create a contract that will have all the points in it that we need. How much work does the back end have to do to provide that application document? So what they're doing becomes very important. The next thing we can think about is where they're doing it from. Now, traditionally, we've thought about where as being a geographic location, but that's started to change quite a lot now as well. Not only is the load coming from somewhere in the country, throughout Europe, around the world, but also the where starts to go a little bit back to the what they're doing, but also it goes a little bit forward to how they're doing it. What I mean by that is a simple example that we can look at. Once again, we've got a group of internal users. Now, traditionally, we've thought of those people as sitting in an office with the wonderful open plan office that everybody provides us, which is supposed to help us collaborate and work together. It's irrelevant the fact that most people put headphones on now because the office was getting noisy and I'd like a bit of quiet. But traditionally, we looked at our internal users as being based in an office. And so there was a lot of traffic that was coming from those geographic locations. We had a group of external users, and as they would be spread around locations throughout the world, countries, Europe, whatever. But unfortunately, in the last sort of 18 months, 2 years, we've had a bit of a change. And so what's happened now, of course, is that there's a lot of, how could I put it, empty office space that probably today still exists. And so our load has changed. So this is why that where has almost changed the context a little bit as to what we're doing, how we're doing it. Because of course, I can still access everything that I need sitting in the luxury of my own home. So the work that I do today is definitely work from home. But how has that changed the transactions I'm now doing? A very big part of the work that I've done, certainly going back beginning of last year, sort of into last year, was helping businesses get their VPN up to scratch. Rather than have 10% of people working from home, suddenly everyone was working from home. So how did that change the way that we worked? If I've got a client on my local machine, it might be passing back big lumps of data every once in a while. And that's a very different load model from a virtual desktop that's passing little bits of stuff backwards and forwards frequently with a server back in the organization. So there's things like that that we can look at as well. That's very much around the where part of it as well. So we've still got to think in terms of geographical dispersion, but it's the way that that has changed. So rather than coming from a couple of big office locations, now our business systems, certainly if I'm working as an internal user, might be much further distributed. So we need to go back and rethink about our load distribution, about the way that our users are accessing our systems. Another big point that we need to look at is, when is stuff happening? Now, this is really interesting because traditionally we've looked at the internet as a thing that's almost always there, but it followed a common pattern. There'd be a little bit of traffic early in the morning, and then that would drop off. There'd be a little spike again at lunchtime. And then in the evening, as kids started to get home from school, as we would get home from work, the internet usage would start to ramp up. And then from about 7 in the evening up until about 10 or 11 at night, that's where we would spend or we would use up the most internet bandwidth. So we'd all be, playing our online games or streaming media or whatever activity. Interesting thing about that is that people think, oh, games take up so much bandwidth. No, it's not. Netflix takes way more bandwidth than online games will. But it was that pattern that people got into. Now what's happened is, working from home, that model has changed a lot. And there's a really interesting effect that's starting to happen as a result of that. One of the really interesting things now is the where is almost becoming the when. So a very good example is, at the moment, I work with a lot of colleagues, folks over in India. I'm based in the UK. Now, if we think about that, we say, well, okay, hopefully the bandwidth's good in India, and yeah, it will be. But think about the time of day. So as we're coming up to lunchtime, what time might it be in India? Well, that's where the, people are getting home from work, school, and that's where our internet is starting to ramp up. So if things start to slow down for people in the afternoon when they're working in Europe, it could be because they're well into this is the really busy bit of the internet day. So we need to start thinking about not only when stuff's happening, but also linking that to the where that we mentioned earlier on, because of that pattern of traffic. So yeah, to people that are using a remote desktop in India, and it's in the afternoon in Europe, yeah, you're right in the middle of your busy internet time in India. If you're working with folks in the US, it's exactly the same for people in Europe. So that idea of global working, well, yeah, we can do that, but we have to think about it in the context of, how's it affecting other things. So we need to know our load distribution. Sorry, our time of load distribution, I should say. When is the busiest time in that service, in that system? What does that look like in terms of external traffic? So are we fighting with a whole lot of Netflix and chill, for instance? Or maybe more the Netflix than the other bit. And then that brings up the how. Now, we could think about that in terms of technology. So everything from a smartwatch all the way up to a desktop machine, we might be using all of those different ways of accessing that service or that system. each one of those are going to be hooked up to some sort of internet router. So are you an old-fashioned sort of cable kind of person? Are you online? Are you sharing bandwidth with your son who's sitting up in his room and is a little bit annoyed because he can't get online because dad's doing a webinar? But there's some other things we've got to think about as well that I mentioned before. So if we're all now using the ISP to access work, and then, as work slows down, the, YouTube videos start up, or even those that are working while they're playing YouTube videos. Certainly not while I'm performance testing, of course. I don't want to affect the bandwidth. But there's other things that we can think about as well in terms of how. One of the interesting things is the way our users actually perform the business processes. And it goes back to the user. How is the user thinking about this particular service or system? Because it is very much related to the steps that they're going to provide as to the path that they're going to take through that system. So here's an example. Let's say that we're going to book an online flight, and we're going to go to one of my, I won't say one of my favorite destinations, but I've certainly gone there a lot, and that's Dublin. So I've flown from London to Dublin very frequently. Now, if we're going to book a flight to Dublin, might be going to the Jameson's distillery, the Guinness brewery. We're going to walk around Phoenix Park in Dublin, visit Temple Bar, look at the Liffey. I mean, it is a nice city. But let's think about the flight we're going to book. So it might be a particular airport. Apparently, I like to say there's 4.5, but there's 5 airports that you can fly from London to Dublin. One's just a little bit further away. So where you fly from might be a consideration. You could pick any one of those airports. The departure time. Are you going to fly in the evening? Last flight is usually the cheapest. Are you going to fly early in the morning? So maybe catch business travelers. After work, sort of, 1700, 1900, a lot of business travelers might be flying at that time. Do you want to avoid that? Fly through the day, for instance. The cost. Do you want to treat yourself and maybe fly in the business class? Or do you want something that's going to be cheap, so you're willing to get that last flight? The seat class. So yeah, once again, you want to treat yourself with a business class seat, maybe even lounge access. So yeah, London City Airport, unfortunately, doesn't have a lounge, at least last time I was there. So you might want to avoid London City, especially when all the business travelers are traveling. In fact, avoid the lounge when there is going to be business travelers traveling, because they all have access to the lounge, and it'll be full of, coats over seats and laptops left set up on the table. Now, you might go through all of those considerations when you're going to buy the flight. I'm different. I'm going to get BA 4470. I don't have to think about any of those at all. That's the flight I get. I get to London City after work in the afternoon. I am one of those business travelers. I get that flight. I'm over in Dublin, sort of 9 or thereabouts. Coming back, BA 4471. So the steps that I go through are very different from most travelers because I do it frequently. And so that's something we have to think about once again, is rather than just say, oh, we've got a group of end users. Well, how are those end users going to react? How many searches might you do before you pick a flight? So these are the considerations that we might have. So it's knowing how that load is applied to your system. That's very much what the how is talking about. Because once again, that could change the profile of that performance test. Now, you might have noticed the world is changing a bit. I have to admit, I love this photo. I'm a bit of a Trekkie. Sorry, all the Star Wars fans, but I am a Star Wars fan too. So I've got to put in both camps. But whether we like it or not, the world is changing. And so we need to think about that in terms of how is that affecting the way that load, the way that performance is being applied. So a good example might be that you might be working on an old legacy system that's being updated to a set of microservices, and things might be getting a lot more complicated in terms of load. So rather than have one big application, we've now got tens of microservices that are running. So where that might look like a bird's nest or a bale of hay, that looks closer to the call diagram for the microservices that I'm working with. So we've got to take into account the complexity of what's happening. Nothing ever gets simpler. We would like it to be, but inevitably things become more complicated. And of course, one of the things we've got to think about is that magical thing called the cloud. I love talking to people about the cloud. I'm from Australia. And so, yeah, the cloud was, you'd look up into a blue sky and you'd see one little, oh, look, there is it. That must be it. That's the cloud. We can't put too much on it, though. It's not very big. But I love it when you get a group of people together and they say, oh, I know, we can put that system on the cloud. Oh, great. That'll solve all our issues. What's the cloud? That's a question I often ask. Well, what is the cloud? Well, it is, yes. We could say that it is a visible mass of condensed water vapor floating in the atmosphere, typically high above the general level of the ground. I like to think of it, though, as something else. It's someone else's computer. That's literally what the cloud is. So you're going to take a system that was internal to your business on your own servers, and we're going to put it on someone else's computer. Gee, could that affect performance? Because the cloud is used as, it's almost, well, the answer is the cloud. Now, what's the question? Oh, it'll make it simpler. It'll make it faster. It'll make it more reliable. Yeah, okay. So we need to think about it in these terms. Back in the good old days where everything was on premises, it was easy. Everything was ours. And so basically all the way up to where it exited our domain through our firewall, we had control over everything. So in effect, performance testing was our problem. It was down to us. We had full control over everything. So we could change configurations. We could, get more servers. We could get more bandwidth. All of that was our responsibility. Now, where the cloud has changed things is we've got all of the as a service. So we can now get software as a service. And that's where basically everything's looked after by someone else. And so examples of that might be online storage like Dropbox, Salesforce, Zoom is probably one that you've used recently, or the Google applications, your mail, calendar, and so on. But the interesting thing is now is I can still performance test that. But I'm now approaching it more from an acceptance point of view, because I've got no control over the code, the infrastructure. So a lot of those earlier levels of testing I can't do. But the influence that a performance tester will have is more around that service level agreement. So that when you sign up with one of the software as a service providers, you need to make an arrangement with them to say, I want this percentage of availability. I want the system to have a certain reliability. Availability and reliability. Availability is I can get to that system. Reliability is I can do everything I need to do on that system. We might need to put in specifications about the amount of load we're going to put that system under and what sort of a response time we're going to get back from that. So it becomes a very detailed agreement that we will have with that software provider. So as a performance tester, I'm now checking against that service level agreement, and I might have a role in writing that. So it's very much a different role for the performance tester. But there's more. There's a platform as a service. And that's where we can use their almost online IDE to write our software, but they still look after everything else. So examples of that is the Google App Engine, Red Hat, OpenShift, Heroku. These are all ways that I can write the systems or the services. But once again, where I might have been looking purely at acceptance testing with software as a service, with platform as a service, I'm now way back at the code level. So I might be looking at the efficiency of that code, because the more efficiently we can get that code to run, the less resources we use, and so the better off we might be. So it's very much a dynamic change that we're looking at. We can then look at infrastructure as a service. So this is one that a lot of businesses might recognize. And that's where with infrastructure as a service, we're buying resources, literally. So what we're doing is we're going to one of the providers, Azure, Amazon Web Systems, Amazon Web Services, I apologize, the folks from Google, DigitalOcean, and I'm buying CPU, memory, and so on. Now, infrastructure as a service is an interesting one because it's a half and half that we're providing. So we're responsible for a bit and they're responsible for a bit. And one of the interesting things that happens here is this is where we now start to look at a particular type of testing that becomes very important, which is scalability testing. So we're looking to see from our friends at ISTQB the degree to which a component or system can be adjusted for changing capacity. So if Glastonbury starts up and we're going to sell tickets to Glastonbury, well, straight away we know we're going to get we're going to need all the capacity that we can handle for a very short space of time, while those 100,000 tickets sell out in a matter of minutes. And so we can look at that. We have to look at it in two different ways. What we're looking at with scalability testing is the ability of a single pod. So this is our little environment that we've got running in our infrastructure as a service. So we've got our little operating system, we put our code on there, and what we want to do is we want to first of all do what's called vertical scalability. So we're going to increase and decrease the amount of resources available for that pod to try and get that code running as efficiently as possible. Because remember, we're paying for those resources. What we can then do is look at the possible load that's going to hit our system. So we might be quiet for a period of time, but then the business might ramp up. And so what we might look at then is how many pods do we need to be able to spread that load to be able to service all of those people that are wanting to use our services or our systems. So it's very much different from some of the other examples that we've seen. So it's very important when folks at work start to talk about the wonderful solution of the cloud, we need to know which of the as a service they're talking about when they mention the cloud, and how that's going to apply to us, not only as business users, but also as people that potentially want a performance test. So we've talked a bit there about the technology, the back end, the stuff that our systems are running on. But we have to return back to that human factor once again. And there's three fundamental factors that I think that we need to be conscious of as people interested in performance. The first one of which, of course, is usability. So there's a real trade-off there in terms of usability, we might want to have all the lights and bells and, have dynamic searches going on where we start to type something in and all of a sudden there's a list of things that I could pick from. And our users are going, wow, this site is so good to use. But how could that usability affect performance? We've got security. Lots of people can access the internet today, and some of them aren't nice. And so what security do we need to put onto our as a service that we've got there? If it's online, you've got to assume that bad people will get to it and try and break it. So we need to add in our security, encryption, decryption, being able to protect our users' data. And of course, the third aspect is the performance. So we can look at usability, security, and performance as sort of being the corners of a triangle. You would like a nice equilateral triangle, all sides are the same, but a lot of the time it's a little bit bent out of shape. Because if we change one of those things, it could affect the other two. So they're very closely related, those three things together. But it also goes back to that point that I've been mentioning earlier on. And that goes back to this, it's a new term in applied psychology called cyber psychology. And this is a fascinating area. This is something that I think as performance testers or as testers in general, we need to start to think about. Because there is some really interesting work going on. There's, particular psychologists, authors are writing about this stuff. And I think we can apply it a lot to the stuff that we're doing. So how do we interact with others using technology? There's a good example of a couple of uni students who were told to sit in front of a whole lecture theatre and have a conversation, sitting face to face. They didn't know what to talk about. So the lecturer then had two devices hooked up to the big screen, turned them around so they weren't facing each other, gave them these two mobile devices, but everyone could see what the conversation was. And it was astounding. They couldn't type fast enough for the conversation that they were having. How is our behavior influenced by technology? So not just in terms of usability, but the way that we put together a business flow, a service or a system. How can technology be developed to suit the needs of the user? So what is it that users want to do in a system? And how can our behavior and our psychological state be affected by the technology we're using? Hey, if the website's slow, I will be angry. Easy. Difference is, of course, I won't just be angry at the website. I might be angry at the ISP. I might be angry at a whole range of different people, depending on how I'm connecting with it. But it's something that we as testers can think about because of the fact that a business owner or a product owner, I should say, a business analyst might look at a system. And there's a good example. Many years ago, I worked for a company that was doing online betting. And their business people said, right, this is what a user's going to do. They're going to log in, they'll place a bet on the next race. I went to a lot of horse races that did look like that in Australia. They watched the race. Okay, did I win? If they won, they're going to have a particular psychology. And so they might jump in, they want to collect their bets, they want to go and spend it. So the business thought, yep, they'll go in, they'll place their bet, they'll win, and then they'll log out and go and do something else. What the users actually did was something quite different. Because, of course, not many people win on the races. So it was interesting to see the breakdown. And what they found was the server was getting under stress because it was having to support much more load. But it was supporting these idle sessions. And when they started to look at the system, they actually found that the users only logged out 2% of the time. So they actually clicked on the log out button. 98% of the users would close the browser in anger or go to another website, and the session would stay running on the server. And as a result, their server was having to maintain a whole lot of sessions. So they thought they'd solve that by going in and playing with the session timeout. But that then affected the users, because a user might be letting the session sit idle for a moment, and all of a sudden they go back to it and they've logged out. So it's a really simple example of how our behavior could be affected by the thinking of those product owners, of those business users. Our users will use it this way. Well, have you asked? Have you checked? So we have to remember those guys. We have to remember how they're going to interact with the system. We have to remember always that there's going to be a lump of meat sitting behind the keyboard somewhere. And what's the stuff that we do going to do to them? So when we're looking at performance testing, we have to go all the way back to the start and think, okay, let's look at it from that user point of view. What do we mean by performance? Who, what, where, when, how? Special emphasis on the who. We need to adapt the work that we're doing to suit that sort of now in the cloud approach. All right, all those different as a service that the cloud represents. How might that change the work we're doing? And the final point, don't forget your users. All right. The user might want it in 2 seconds. Well, why do they want it in 2 seconds? What happens if it's 2.5? What happens if it's 2.8 seconds? Is a user going to care? So we have to think about it from that user perspective. All right, that's enough of me rabbiting on about performance testing. Let's go over to your questions. So let's see if we've got any questions from anyone.
Keith, thank you as ever. Packed full of information and thoughts and ideas. So thank you very much for that. We're a little bit up against the clock, but let's just cover a couple of questions that have been asked about. First of all, one of the challenges that performance testers might face is choice of tools. Have you got any quick and easy tips about that you could share?
Indeed. Well, as chance would have it, I'm using JMeter at the moment. So JMeter is great, open source, wonderful little tool. A little bit fragile. If you update Java, you tend to break the tool. Also, the tool itself, JMeter doesn't do well in terms of monitoring. So you usually have to go out to another sort of monitoring tools, something like Prometheus or AppDynamics or Splunk or something like that, because you can't get a lot of data back. There's tools like LoadRunner, for instance, which is at the opposite end. It's very much a commercial tool. You pay lots of money, but you get a wonderful tool that can do all sorts of monitoring. So the tool market is changing a little bit. And really what it comes down to is how you look at the systems that you're testing. There are tools that will suit your system. There are some that won't suit it. So it very much depends on what's being built and how it's being built as to a tool that you might want. Gone are the days now where one tool will do everything. It just doesn't work like that anymore.
And is it possible with some of these tools to do a kind of a proof of concept to see which one's going to fit your situation the best?
Well, that's hit the nail right on the head, because you can listen to the salespeople and they'll tell you, yes, this tool can do everything. So your next question would be, well, show me. You would always do a proof of concept. In fact, it might be an existing tool that you've had for years and years. You might want to do a proof of concept on it right now to see if it's going to be useful on the next job.
Yeah, makes sense. CI/CD, everybody's talking about. How does performance testing fit with continuous integration, continuous deployment?
Ooh, that's a good question. In 2 ways. What happens is with CI/CD is everybody gets in and thinks, oh, right, we're working with the developers. And so they're going to build a little component and I'm going to go and test it. And I have to admit, I've been doing a lot of that. But the problem you get with that is that, and it sounds really strange for me to say it, but we've shifted left. So for years and years as testers, we've all said, oh, we've got to shift left. Let's do more at the components level. The problem is that now we're concentrating too much at the component level, and we've actually got to, it sounds a really weird thing to say, but we've got to shift right a little bit. So what tends to happen in the CI/CD space is you've got performance testers that are working within the sprint, within the development teams themselves. But we also have to think about people outside of those teams. So it's almost that you've got to take a step back and think about it more from an end-to-end perspective. So you almost need a two-stage performance testing strategy. Do all the stuff early, upfront, get all the benefits of that early component testing, but don't forget about the end-to-end testing that we need to do later on with everything integrated together and maybe with a user interface stuck on the front.
Thank you. I can see that the team are putting across here a banner about booking the Certified Tester Performance Testing exams. So a little bit of a plug there for the certification. You know, when you're looking at training and which direction to go, you know, some people might say, well, go tools training. Other people say, well, the ISTQB has something to offer. Could you just maybe give us a little summary of why the ISTQB certification may be of use to performance testers?
Indeed. For many, many years, I ran the load runner training. You would learn to use the tool. So, oh, yes, we're going to do this. And you click this button and do this and do that. But why do I click that button? Yeah. Why do I do these things that the tool will let me do? So the thing that's always, well, I won't say always lacking, but the thing that was lacking a lot with the tool courses was the process, that actual load test methodology that sits behind it. And that's what the ISTQB course covers. It goes through a load test process in a lot more detail. It doesn't talk about specific tools at all. So there's still benefit in going away and doing a tool course, but you won't get the benefit of that underlying process unless, of course, you do one of my courses, because then I give you that for free. But yeah, that's the big issue that you get, is that you don't get that process. And that can be a big problem, because unless you know why you need a performance or a stress or a load test, a scalability test, well, they're all just words.
Mm-hmm. I'm just going to give a quick shout out here from Kiran from India, who says, thank you for a wonderful session, Keith. He's saying, with companies adopting public cloud infrastructure, AWS, Azure, GCP, and moving application workloads from on-premise to cloud, and it's quite a long question here. As you have almost infinite capacity to scale in, out, and system components are automatically fault tolerant, what is your opinion on this?
It's a very relevant question, Kieran. Thank you for that one. There's one thing in particular that I've never trusted, and that's load balancing. Now, this is something that some of those services will do automatically. I'm always a bit suspicious, because up until the cloud, load balancing was always something that was left out of a performance test, but it was a place where things would quite often go wrong. So don't get me wrong, I love automatic stuff. If I can use an automated system that will do some of the things that we're after, then yeah, by all means. That point on scalability is a very good one, because we might need to fire up more pods, but have we tested that? So my question would be, use the automatic systems to your heart's content, but make sure you test them first.
Thank you. Thank you ever so much. Thank you for Kieran for that. Keith, as always, we've gone a little bit over here. We're coming up for 8 minutes over. So I'm going to say a big thank you to you, and hope you'll come back again soon and join us for another session. And thank you for everybody who has spent this time with us. I'm going to wish you all a very good weekend and say thank you for joining us. And Keith, see you again soon.
Cheers, Debbie. Thanks a lot. Have a good weekend, all.
Yeah. Bye. Bye.
Bye for now.
Bye.